Hello students, I hope you have solved the numericals which was given in your last assignment. This is the diagram of a Vernier Caliper. We have studied that Vernier Caliper is an instrument that can correctly measure the length up to second decimal place of a centimeter and 1 decimal place of a millimeter scale. And the least count of a Vernier Caliper is 0.01 centimeter or 0.1 millimeter. Now let us say we have to measure the length of a very thin wire lesser than this 0.1 millimeter, or we have to measure the thickness of the paper. For such thing, if we use this Vernier caliper, this will not give us the accurate measurement. So here is an instrument which is called screw gauge, which is used to measure the diameter of a wire or the thickness of the paper, usually up to an accuracy of third decimal place of a centimeter scale or second decimal place of a millimeter scale. So now let us talk about the construction of this screw gauge. As you can see the diagram which is given on the screen. The diagram of the screw gauge is also there in your book, figure number 1.7. Now let us discuss about its main parts and function. Very first, ratchet. The ratchet is here at the back. This is the ratchet at the one end. It is used to advance the screw by turning it till the object is gently held, the stud and the spindle of the screw. This end, A, which is marked A in your book, and A is called the stud at one end, and at the other end we have end B, which is attached with this nut, end B. In this A and B stud, we put the object whose diameter or the thickness we have to calculate. Now after ratchet we have sleeves. Sleeves is there on which we mark the main scale or the baseline. It is also called the baseline. This is called the slips. On the sleeves the main scale is there. Next is thimble to mark the circular scale. Main scale, it is used to measure the length correctly up to 1 mm. Circular scale, it helps to read the length correct up to 0.01 mm or 0.001 centimeter. At one end A, we have fixed end, that is the stud. At other end, which is the movable end, which is fixed in this U frame, on which the nut is there, N nut, with the help of that nut. After that we have sleeves. On the sleeves we have main scale, which is housed inside this circular hollow cylinder, that is the thimble, on which the circular scale is there, which is also called the head scale. On this circular scale we have 100 divisions, 100 equal parts, and we put the object in between these two studs A and B with the help of the rotation of this ratchet. Now the pitch of a screw. The pitch of the screw is the distance moved along its axis by the screw in one complete rotation of its head. As you can see in the diagram, the distance which is given by P, or we can also say that the distance between two threads is called the pitch. 2 consecutive threads. The linear distance which the screw moves in one round is equal to the distance between 2 consecutive threads on it, and this distance of these 2 consecutive threads is also called as the pitch. We can also define like that. Next is least count of a screw gauge. So the least count of a screw gauge is the ratio of pitch of the screw by total number of divisions of the circular scale. The circular scale has number of divisions. Sometimes it has 100, sometimes it has 50 divisions also. So according to that, it is the ratio of pitch of the screw by total number of divisions on the circular scale. This is how we calculate the least count of a screw gauge. Now the most important question, so many times they have asked, what are the ways to decrease the least count of a screw gauge? As you can see from the formula of the least count is, it is the ratio of pitch of the screw. That means it is directly proportional to pitch. So when we will increase the pitch, least count will increase. When we will decrease the pitch, least count will decrease. So we have, now they are asking the ways to decrease the least count. So we will, the very first is to decrease the pitch of the screw. Next point, that is by increasing the total number of divisions of the circular scale. It is inversely proportional. So when we will increase the number of divisions of the circular scale, least count will be decreased. Very important point it is, learn it. Next is zero error. As you know, zero error in Vernier Caliper. Just like this, here also we have zero error. That means when we bring both the objects, that is flat end and B, closer to each other, in contact with each other, and if the zero mark of the circular scale coincides with the baseline or zero of the main scale, there is no error in that screw gauge. But sometimes due to mechanical error, on bringing the stud A and B in contact with each other, that is the zero mark of the circular scale does not coincide with the zero mark of the main scale or the base scale, then the screw gauge is said to have zero error. There are 2 kinds of zero error: positive zero error and negative zero error. On bringing the flat end B of the screw in contact with the stud A, when the zero mark of the circular scale is below the zero mark of the main scale, as you can see in this diagram. Here the zero of the main scale and zero of the circular scale coincides with each other, that means no zero error. Here when the zero of the circular scale is below the zero of the main scale, then this type of error is called positive zero error. Negative zero error, diagram number C, when the zero mark of the circular scale is above the zero mark of the main scale or the baseline, then we can say that this is negative zero error. All these 3 diagrams, please go through it. No zero error, positive zero error, diagram number B, diagram number C, negative zero error. Now, corrections due to zero error, that is correct reading. The correct reading is equal to observed reading minus zero error with sign. And how to calculate observed reading? Same as we have done in Vernier Caliper, that is main scale reading plus circular scale reading. Here we have circular scale reading instead of Vernier scale reading. So go through this formula of correction, that is correct reading is equal to observed reading minus zero error. Thank you.